All right. So here is an example of the 80-mile trip type of question where, you've got average velocities and you've got to figure out how fast you want to go for the remainder of the trip to average a certain velocity here. So here is, like I said, a typical question. We want to go 200 miles, averaging 60 miles an hour. Halfway there, we've averaged 75 miles an hour. How fast must you go the remainder of the trip to average 60 miles an hour? So what you've got to look at here is that in order to average 60 miles per hour, we have to go that 200 miles in a certain amount of time, right? And so the first thing we need to do is we need to figure out what is that time. Now, what I like to do is draw a nice barrier here. And so then I label this first part here, the whole trip. And then we do the first half and then the second half. Now, the reason we do this is because this is constant velocity. We're going to have an average velocity for the whole trip, but we're going to have a constant velocity during the first portion. We're going to have an average velocity during the second portion. That means they each get their own unique equations. So when we're taking a look at the whole trip, we just need to run through this equation right here, where velocity equals delta D over T. Right? Now, plugging in, we know that the velocity needs to be 60. We know that the displacement is 200 miles, and we don't know T. So if we solve for T will be 200 divided by 60, which, if I'm doing this correctly in my head, comes out to be 3.33. But let me just run it through a calculator to be sure. And yeah, okay, so let's erase this, and I'll write it over here somewhere, that the total time ends up being 3.33 hours. Okay, now in the first half of this trip, we have used some of that time. We need to figure out how much of our time budget we have used. Now, the trap that people fall into on this problem is they look at this 75 and go, well, that's 15 over. If I just went 15 under, so if I went 45 miles an hour, I would average 60. The problem with this is that you are averaging averages, and averaging averages does not work. All right, it is incorrect. You cannot average averages. You are allowed to average instantaneous velocities, but not average velocities. These are average velocities. A big clue to that would be it says averaged 75 miles an hour. So instead, what we must do is we must find T1, so the first part of this trip. So we are going to use the same equation. We have to use this equation because this is the only equation we're ever allowed to use when we are dealing with constant velocity. So we know that the average velocity was 75 miles an hour. Halfway there, you should be able to figure out in your head that halfway there means 100 miles, right? That does not refer to time. That refers to how far you've gone. And so when we do this, 100 divided by 75, I believe, is 1.33. But again, I'm going to run it through the calculator and make sure I know what I'm talking about. And it is. It comes out to be 1.33 hours. All right. So what that means for the second half of the trip is that I now can figure out how much time I have left in my time budget. I have 3.33 hours in my total budget. I have used 1.33 hours out of that budget. So a simple subtraction will tell me I have 2 hours left. And so all I have to do for the remaining 100 hours, or the remaining 100 miles is I just need to go, I just need to drive those in 2 hours. So again, we're going to use this equation because it's the only equation we ever use for constant velocity. And so the average velocity comes out to be 100 miles over 2 hours. And voila, I get 50 miles per hour. All right. Now, you'll notice that is not the 45 miles an hour that we kind of had anticipated, or that we thought you might have thought it should be. Again, averaging averages doesn't work out. You actually have to calculate how much time is left in your time budget. Once you do that, then you can calculate your average velocity from there.